So, hello guys, my name is Max and welcome to this video today. We're going to program this simple Pong game using JavaScript and HTML. But we have some coding to do, so without any further ado, let's start coding our application. Let's start here by creating a new file called pong.html or whatever, and in here just grab some basic HTML, set the title to Pong or whatever, and set a script tag to the body, or add a script tag to the body. So you can start off by declaring the width and height of the application, and in this example let's use 700 pixels for the width and 600 pixels for the height. I also like to keep a static reference here to the method pi constant using this lowercase pi variable for convenience. And to update our game state, we need a canvas and a key state. Sorry, a canvas, a content, and a key state. And for our logic, we need a player, the AI, and the ball objects like that. So now I'm just writing out the skeleton functions here for game. So we need a main function, a init function, update function if I figure out the spacing, and lastly a draw function, I guess, like that. And at the end there, just make sure you call the main function so the game will actually kick off, start. So we can create our canvas here, so document dot create element canvas like so, and let's set the width of canvas, so canvas a width equals to the width with a clear, and the height here to the height with a clear. Now just grab the context from canvas to the context, that is, so context 2D, and let's append it to the body of the document, so document body.append child canvas. Then just call the init function and create this helper function here that I like to call loop, like so, and in here we just call the update the draw functions. Then we just use the window request animation frame for our game loop to update here, so that we take the loop function and the canvas element as arguments there. So we can start by initializing our player, AI and ball, and they're all pretty similar here at the start, so we can do all of them at once. So they will all have X field for the X position at canvas, or in the canvas, and a Y field for the Y position, and we will have an update method and a draw method. And the draw method are pretty much identical in all of them, since all are drawn as rectangles, so we just do this fill rectangle method here, and the X and Y position like so, and then we just have the width and the height here as two fills. So for the player and AI, it's the width to 20 pixels and the height to 100 pixels. And since the ball is drawn as a perfect square, it will only need one length here, the side length, and that will be used for both the width and the height here, like that. So if we now go down here to the init and set a start position of all of the elements here, so the player will be offset from the left side of the canvas by the width of the player, and the Y position will be centered at the middle of the canvas here, so that's just the height minus the player dot height divided by 2, like that. And for the AI X position, we'll offset that from the right side by the player, the width, and you can actually do it like this, plus the AI dot width, like that. And then for the Y position is the same as the player here, so we just do like so. And for the ball, we'll just be centered in both directions, so ball side divided by 2 for the X position, and the Y position is just the height minus the ball dot side length divided by 2. So now if we go down here to the update and the draw, and just call player.update, AI.update, and last the ball update, I guess, and then change all of those here to draw. And if we open this up at the browser, we should hopefully see this picture drawn for us. But as you can see here, I have this embossed theme going, where I draw the paddle and the balls in white and the background in black. So let's do that for our application as well here, or our game. So just go back to Sublime Text, and yeah, so we can just do a fill rect here, the 0, 0, and the width and the height, like so. And then set the fill style to white, like that. But before we do that, let's actually save the context. And let's store it here at the bottom to ctx.restore. That should hopefully give us this. So we can draw the net now when we're at it in the draw function. So the net will have an x position, and that will be equal, actually it will have a width first here, and I've set that to 4 pixels. And the x position, it will be the width minus the width here of each of the elements, divided by 2, or times 0.5, like that. And then the y position will be 0 at the start here, and then we need a step size, that will be the height divided by some constants, let's say 15. And we can say y is less than the height. Then we just want to increment the y here with the step value. But before we do that, we want to do a fill rectangle here with the x position, the y position, plus the step size, a quarter of the step size, so 0.25, and then the width and the step, half of the step size here. So if we've done this right, we should see the net drawn. And if you take a bigger number here, that will give us more dense net, like so. Yeah, so that's it for the draw method, guys. So we can do some updating, and let's start with the player here. So we need, for that, we need the key state, or capturing the key state, and we just add event listeners to the body here to capture them. So key down event, we want to call this event callback function, like so, and then we have the key up. So in the key down, we just want to set the event.keyCode here to true, like that. And in the, I put a y there, and then in the, when we release a key, we want to delete that post, or that, yeah, that key value pair in the JavaScript object. So we just want to delete the key code here, so like that. So if you go to the top here and just set some key values or key codes here, so we have the up arrow as 38 and the down arrow as 40, and then we just update here accordingly. So we say if key state up arrow, then we want to subtract from the y value, let's say 7 pixels. And when the down arrow is pressed here, so we want to add to the y value. So for now, I should be able to control the player panel. Yeah, that seems to be the case here. So that's good. So now I can do the ball update. So for that, it will need a new field here that I will call velocity, or vel for short here. And I set it to null at start here, and then the speed value, I'll set that to 5 for now, like that. And then in the init method, just make sure you set the initial velocity for the ball here, so it equals to the x. We can set that to 0 for now, and then the y velocity to the ball dot speed, like that. And hopefully now the ball should be going downwards. Oh, sorry, we need to, of course, update first here. So we just want to update the x position, so this of x plus equals this dot velocity dot x, and the y position with the y velocity, like that. And now the ball should be going downwards. Yeah. So we need to listen here if the y position is less than 0, or the bottom, the bottom of the ball here, so this dot y plus this dot side, if that is bigger than the height, then we just want to mirror the y velocity, so this velocity of y times equals -1, and that should give us a bounce-ness here, collision with the edge of the canvas. But if you put say some ridiculous number value here, so let's say for example 50, you can see that the ball is going inside of the canvas border. And to fix that, we need to calculate the offset, and that is of course depending on which direction the ball is going. So we set, and for that we can just use this ternary operator. So we can say this dot velocity of y is less than 0. So if the ball is going upwards, then we just want to take the 0 minus this of y to calculate the offset. Else, do we want to take the height minus this dot y plus this dot side, like that. And then we just add the offset to the y position, so this y plus equals the offset. And that now you can see that the ball is going all the way to the end of the canvas here. But it's actually not a perfect elastic collision here. So to fix that, since some of the velocity is lost inside of the border here, we take 2 times the offset to fix that, and we now have an elastic collision that is perfect or fit well for this example game here. Yeah, so that's good. So that's it for the Y collisions, and let's put this back to, let's say, 5 for now. And before we go any further here, let's just center the canvas here. So for doing that, we just set the position to not static, to absolute, and then the margin to auto, and then just by setting the position attributes here to 0, it will center it in most of the browsers. So the right to 0 like that, and now we have the canvas centered. So we can do the X collisions here. So we do it like by setting the velocity here to the X, and now the ball should be going to the right. And to check if it hits a box here or rectangle, we need a helper function in the update method of that ball here. So I will call that AABB intersect, and that will just return true if 2 axis aligned bounding boxes, so 2 boxes that are aligned with the axis of the canvas coordinates. If they intersect, it will return true, else it will return false. So it will take a X position, a Y position, a width and a height of the first bounding box, and then the same for the another one, so b.x, b.y, b.w, and b.h. And then I could go into the math here, but for now I will just show it for you here. So it will just return ax is smaller than the bx plus bw, and ay is smaller than the by plus bh, and bx is smaller than the ex plus aw, and by is smaller than bay plus ah. So this will just return true if 2 boxes are if they intersect, else it will return false. And then, so we doesn't need to check against both of the paddles, since we are just interested in the right paddle when the ball is going to the right, and the left paddle when the ball is going to the left. We can use a ternary operator here as well, so we can just say the paddle equals to this velocity of x is smaller than 0, so if it's going to the left this time, then we want to check against the player, also want to check against the AI paddle. And then we can just say if AABB intersect of the paddle dot x, paddle dot y, paddle dot width, and paddle dot height. So if that intersect with the bounding box that is this dot x, this y, this dot side, and this dot side, like that. So if they intersect, then we just want to mirror the x velocity, like that. And for now the ball should be bouncing back and forth between the paddles. And if I miss the paddle here, the ball should be going out of the canvas. Yeah. So but this is a bit boring, since it doesn't depend on where on the paddle I hit the ball. The ball will just go in this elastic collision between back and forth between the paddles. So to do it a bit more fun, we can calculate the height normal, so or the normalized value on where on the paddle the ball hits. So to do that, that's quite simple. I just call it n here. We will just take the what do you say? The y position of the ball plus the side length minus the paddle dot y, and then just divide that by the paddle dot height plus this dot side. So that will give us the normalized height offset, that so a value between 0 and 1 on where on the paddle the ball hits. And then we could use that value to calculate the reflection angle that I was called 5 now. And that is calculated by taking 2 times the n minus 1. So this will give us a value between +1 and -1. So then we can just what do you say? Multiply this by an angle in radians. So 0.25 times pi, that's the same as pi over 4. That is the same as 45 degrees, if you're not that familiar with radians. So it will give us a 45 degrees reflection angle when it's hitting at the top here, and also a negative 45 degrees angle up when it hits on the top of the paddle, and a positive 45 degrees angle when it's at the bottom of the paddle. And then we could just update the velocity accordingly here to the, so we can say this dot speed times math.cosinus of that angle, and then we could just take the y velocity to this dot speed times math.sinus of that angle, like that. And as you can see now, it won't work, but if we use this value, or actually when it's hitting the right, it should go to the left, but this will give us a value between 0 and 1, or 0 and about 0.5 and 1, I guess, this value. So for that, we could just use another ternary operator here. So we could say if the paddle is the player, then we want to just take 1, else do we want to take -1. And hopefully now the ball should be bouncing forward. And if I hit on top here, the ball should be going upwards, and if I hit on bottom, the ball should be going downwards. Yeah, but as you might have noticed, we haven't calculated the right offset here. But since we are changing the velocities here, we want to calculate the offset the same way as we did up here. So we will just set the x position depending on if the paddle is the player or the AI. So you can just say if the paddle is the player again, then we want to set the x position to the player.x plus the player.width, like that. Else we want to set it to the AI.x minus this.side, like that. So we will lose some of the velocity here, but it is work well in this example here. So that's it for the reflection. So we have more or less just copy out. We have some minor details left to do, so let's do the AI now, and we'll just use a very simple AI, not very smart or anything. So we'll just calculate our destination on the y-axis where we want to go here. So that is just the ball.y minus this dot height plus minus the ball.side divided by 2, like that. So that will also times 0.5. So that will give us the y position of the y-axis the ball wants to go through. So now if you just set this dot y equals to the destination position, the paddle should follow the ball here at all times. So yeah, you can see here. But that's a bit boring since we won't be able to beat the AI. It is impossible. So to do that, we could just use this flashy way of doing stuff. So we just subtract by the y value, and this should be, we just add this here, and then we multiply this by a small number, let's say 0.2, and that should make it possible for us to theoretically beat the AI here. Yeah, so now we can see that it isn't reflecting a straight line from the AI anymore. Well, now it was, but yeah, you get the point here. But I guess that's a bit too fast here, so we should change that to 0.1. And let's increase the speed here to 12. And yeah. And I should be able to beat the AI. So yeah, now for then. Well, let's add a smashing system to the game. So if we can say if the absolute value of the angle is bigger than some value, let's say 0.2 radians. So we take the absolute value here of the angle and check if that is bigger than 0.2 pi here. So about 36 degrees, I guess. If that's the case, we want to set the smash value to 1.5, else we want to set it to 1. And then we can just multiply that smash value at the start here. So if we hit I guess I screwed up here. This should of course be phi. Yep, so if I hit on the top here, the ball should be smashing, so let's see if that's the case. If I just hit it. Yeah, there, you can see that the AI smashed there, and there I smashed. And there you could see that I could win over the AI. So that's good. So we have just, yeah, one thing here left to do is maybe to check if the X position is smaller, or you can add a side here, if that is smaller than 1 or 0, or the X position is bigger than the width of the application, then of course we want to set the start direction and all that again. So let's go down here to the init. Let's just copy this. Let's copy it in here for now. Like that. So now if I hit it, yeah, so that's good. And we will of course want the X velocity here to be depending on which, who the pedal is, so we can just use the same thing as we did here, or sorry, here. Just copy this, take it down here, add it like that, and I'll see if that's the case. Yep. But this can be a bit abusive, so you can see if I just stay here, I will always get a point. So to get rid of that, so to speak, bug or exploit, you could add a surf function to the pedal, and that should be the last thing to do here. So let's do that. So let's add a surf function here at the top. And as a parameter, it will take which side the ball should be going. So 1 if it should be go to the right, and -1 if it should go to the left here. And for this, we just take a random value between 0 and 1 here, that I, of course, is equal to the math of random. And then we set the X position depending on the side. So if the side is 1, also then so if the ball should be going to the right, then we set it to player position, and if it should be going to the left, we set it to the AI.x minus this dot side. So the same as we did here I guess. Yeah. So I should set the X position, and then for the Y position, we take a random value, random value on the Y-axis. So we take the height minus this to the side. We must multiply that by R. And then for our out angle, we calculate an angle again. But this time we do it in the other direction. So we take 0.1 pi times 1 minus 2 times R. So that should give us a random value or angle depending on the R here. And then we just set the velocity, so this dot velocity like that, and the X, we just take the side and multiply that by the speed and the math of cosinus of that angle. And then for Y, we just take this dot speed and multiply that by the sinus of that angle. Yeah, so that's it for the surf function. So now instead of doing all of this, we'll use the surf here. So we can keep this, I guess. So we can just say this dot surf like that. Let's just get rid of everything else. So all this, and like that. And then here in the init, we could just get rid of all of these as well. And just say all dot surf. And I guess we can set it to 1. That should, yeah, so now if I miss, the ball should be going in a random fashion here in the surf function. So that's it, guys. So that's the complete game there for you, and I will probably do a second video of this where I add a score system, but I guess this video is longer enough here. And yeah, so I hope I see you then, and thank you for watching. Yeah, so I just realized that you could go outside of the border with the pedal and the AI. And to finish that, that's really simple. That's just one line of code to add to the update functions of the player and the AI. So let's do that real quick here. So just go down here to the ball.update, the AI.update and the player.update. And here we can say this.y equals math.max of math.min and like that, so that the maximum value can only be 0, so that will stick it to the top of the canvas, and the minimum value will of course be the y value or the height minus this dot height, like that. So that should restrict it to be only inside of the canvas. And I realized I had one more thing here in the serve function. So you could just add the width. You should add the width of the player here to the x position, so it should be the same, exact same thing as we have here. So hopefully now, if we can't we go outside of the canvas anymore? And yes, that seems to be the case. And when we serve here from the player side, you can see that the ball is going from the edge of the paddle here. So yeah, so that's it, guys. And I hope I see you in the next video. Thank you for watching. Bye.